This video will begin by providing the critical position statement of Indonesia on microgrids. The position Indonesia holds on microgrids is one of ensuring a reliable flow of energy with a focus on national development, contrary to the global shift towards climate sustainability. Following from this, a critical response to this position statement is provided from the view of the USA, who are mostly using microgrids to secure the vulnerable grid, with mainly layered climate benefits. A microgrid is defined as a group of interconnected loads and distributed energy resources within clearly defined electrical boundaries that acts as a single controllable entity with respect to the grid. Microgrids are either connected or disconnected based on their proximity to the main national grid and can either be fueled by renewables such as solar and wind or using traditional fossil fuel sources. Some of the key benefits of microgrids can be rural electrification and climate change mitigation. At COP26 and COP27, it was established that microgrids are a solution to tackle the risks of climate change, improve electrification of developing countries, and provide means for a global transition toward renewables. The Just Climate Energy session at COP26 placed connected microgrids at the centre of a sustainable energy solution, illustrated through indigenous usage, whilst COP27 pointed out their worth in improving reliant electricity access in a decarbonising global south. Microgrids can coincide with the IPCC's effort of limiting global warming to well below 2 degrees Celsius, ideally 1.5 degrees Celsius, above pre-industrial temperatures, promoting the 7th and 13th Sustainable Development Goals, which are affordable clean energy and climate action, respectively. Indonesia comprises over 6,000 inhabited islands, many low-lying, densely populated, and in danger of the adverse consequences of global warming and sea level rise. Their target of net zero by 2060 is deemed highly insufficient based on their current progress. Therefore, the sustainable electrification of the nation poses a multi-dimensional problem. The main force pushing Indonesia towards use of microgrids is ensuring a reliable flow of energy, which in turn feeds into their national development strategy as Indonesia aims to become a developed nation by 2045. This involves the electrification of the country, with over 590,000 people currently disconnected from the electricity grid. Governance strategies are implementing microgrids for the sole purpose of development, meaning any climate benefit of microgrid usage is latent and unintentional. One example of implementing microgrids for this purpose is through the Bright Indonesia initiative. The scheme uses disconnected microgrids to provide electricity to remote areas. These are often in hybrid form, using both solar and diesel power. Solar technology is used to its decreasing cost, yet diesel is the main provider of energy for microgrids throughout Indonesia. Thus, the use of microgrids in Indonesia has little focus on climate change, in contrast to the purpose of climate sustainability highlighted at COP26 and 27. If Indonesia's position shifted to align with the aims of COP, increasing their use of solar-powered microgrids would allow the high solar potential of Indonesia to be utilised. Indonesia is expected to fall short of achieving the 1.5 degrees Celsius target outlined by the Paris Agreement. Therefore, greater implementation of solar technology and microgrids could assist with reaching this goal. The USA counters the position of Indonesia regarding their use of microgrids in the energy mix. Even though the USA possesses a reliable flow of energy in most regions, they require security to protect their vulnerable energy grid. As a layered benefit, the USA also integrates microgrids to help reach their ratified climate targets. The USA energy grid is vulnerable due to three main threats: natural disasters, intentional physical attacks, and cyber attacks. The three examples of Brooklyn, Fort Carson, and Alaska identify contrasting case studies of microgrid implementation in the USA, which can then be compared to Indonesia. The use of microgrids for energy resilience in the US has become increasingly prevalent since Hurricane Sandy in 2012, with the states vulnerable to tropical storms more likely to implement the use of microgrids. The Brooklyn Microgrid project has helped to develop these technologies, using solar energy to accelerate the shift towards carbon neutrality in New York. This will help make the area more energy self-sufficient, protect against electricity outages, especially from those caused by extreme weather, and as a layered benefit of a shift towards decarbonisation. A further example of this is the use of microgrids on military bases in the US, one being Fort Carson in Colorado. These are used as backup energy source, which also can be extended into the local community. Fort Carson is about 550 kilometres squared in size and is a microgrid system with the aim of maintaining energy supply to the base in the case of outages of the main energy grid. The base also has plans to become net zero through the use of renewable energies within the microgrid, though this has not yet been achieved. The primary use of microgrids is protecting the base from cyber attacks against the energy grid. Both of these examples display a focus on the vulnerability of the electric grid in the US, which strongly differs from Indonesia's goal of natural electrification. On a larger scale, unlike the aforementioned examples, statewide electrification in Alaska is challenging, with the main grid currently concentrated in central and southeast of the state. In order to power the indigenous communities that reside in Alaska, there are over 200 microgrids, many of which use diesel. This is similar to Indonesia, who also focus on rural electrification and rely on diesel-fueled microgrids. There has, however, been a conscious effort to integrate renewable technologies in Alaskan microgrids. For example, projects funded by the Alaska Energy Authority explore this incorporation of renewable energy in microgrids, such as through solar photovoltaic technology. This technology is most efficient at cold temperatures and a cheaper alternative, making it a viable replacement to diesel-based microgrids in Alaska. Many of these microgrid implementations are bottom-up solutions. This meets the interest of communities to develop their energy mix sustainably due to cost, as well as the effects of climate change being felt more severely by indigenous populations, as they are highly dependent upon their natural environment. However, indigenous Indonesian communities don't quite have this luxury due to the laws protecting these communities being much harder to enforce, questioning whose voice is heard. Lack of indigenous voice is just one of the causes of climate injustice for Indonesia, and lack of funding from high-emitting developed countries has worsened this. The USA has previously lacked commitment to loss and damage funds, potentially limiting countries such as Indonesia's development. This shows the significance of voice, with Indonesia's energy mix potentially becoming controlled by its funders, compared to the USA, who as the capital make their own choices. If indigenous voices were to be embedded more in Indonesia's microgrid policy, decarbonisation may become more central in Indonesia's changing energy mix. This example shows how microgrids can be used to tackle the challenge of electrifying large, sparsely populated areas on both the statewide scale of Alaska and nationwide scale of Indonesia. It also demonstrates how consideration of indigenous voices can influence microgrid implementation. In summary, the use of microgrids in Indonesia is targeted at improving initial electrification across the country to assist with its development. In contrast, the USA is seen to be using microgrids to secure the vulnerable grid alongside the main electric grid. However, this is not seen to be the case in Alaska, where microgrid usage is similar to Indonesia, with a focus on rural electrification. However, the US appears to be incorporating greater renewable use into their microgrids, such as in Alaska and Brooklyn. While Indonesia is using microgrids for rural and indigenous development, as highlighted at COP, this is often still thought through the use of diesel. Any climate benefits of the use of microgrids in either country seem to be latent or layered, as it is not the only focus of their use. Therefore, it can be concluded that while both countries are using microgrids successfully for development and security, the USA can be seen to be taking a better approach in terms of their use for climate sustainability with greater incorporation of renewable technologies.